So taking a minute, these values, this y value right here is found by taking the 1 and plugging it back into the original problem. That would take me a while to go through on the video, so I'm not going to do that. And the negative 27 is also found that same way by plugging 4 in for here and getting those values. So 1, 0 is actually right here, so I'm going to start to plot that dot. I also can find my y-intercept because it's probably going to cross over here by plugging in 0. So when I plug in 0, I get 0 all the way across and I get 5. So I know I have a y-intercept of 0, 5. So I'll plot that dot. Now after that, I just have to look at how this is decreasing and decreasing some more. So there is no max or min right there, but this still is a critical number for some reason. And then we have an increase here, so I know that there's a minimum at 4, so this ends up being my minimum. And since I can't go down 27, I'll just go down a lot, and I'll just say this is negative 27 way down here. So what happens is I know it's decreasing, and to 1, it's also concave up. So it's decreasing and concave up. Then at 1, it changes concavity and goes concave down, but it's still decreasing. And then once it hits 4, it starts increasing and it changes concavity again, and then goes concave up at that point in time. So this is just a brief sketch of that picture. It's not exact by any means, but we've gotten the idea of it. Increasing and decreasing, you should list down that it's decreasing from negative infinity to 1 and from 1 to 4. It's increasing from 4 to infinity. You should also mark down that it's concave up from negative infinity to 1 and from 3 to infinity. It's concave down from 1 to 3. All those things should be written out. This next example, really, anytime we have an absolute value, what we're going to do with it is just graph it. We know it's a v. We have difficulties taking derivatives of absolute values. We actually don't do that a whole lot because it's just kind of a waste of time. We know what absolute values look like, so let's just sketch this graph. The only thing I will do is I will go ahead and find the x-intercept of this graph. The x-intercept is 3/2. So right there. The y-intercept, when I plug in 0 for the x, ends up being a positive 3. And if I wanted to just get some other points, I could plot them. But I know that because this gives me 0 here, it's where it changes from positive to negative, or where this gives me 0, it changes from positive to negative. So I know the graph just looks just like this. And I would just state that it has a minimum at 3/2, 0. And I would really be done with this because there is no points of inflection. There is no asymptotes. We've found the x and y intercepts. There's really nothing more to do to this one. I will start this last problem on this. Hopefully I'll get through maybe the first derivative. So when you're taking this first derivative, I would go ahead and distribute the first part. And then the first derivative would be 2 plus the derivative of cotangent is negative cotangent squared x. We want to know where is this derivative. So we move cotangent squared 2 and solve. Well, I don't know a lot about cotangent, but I know a lot more about sine squareds, or sine x squareds, because that's what cotangent is 1 over sine x squared of 2. This one ended up giving me 1 equals, once I cross multiply, 2 sine x squared. So I'm really looking at where is the sine of x squared equal to 1/2? Or really, what is the sine of x equal to the square root of 1/2?